Welcome to geometry class. Today's lesson is called Conditional Statements. So, conditional statements in math class are often written as an if-then statement. An if-then statement is a statement such as, if you are reading this page, then you are studying math. A statement that can be written in if-then form is called a conditional statement. The phrase immediately following the word if is the hypothesis, and the phrase immediately following the word then is the conclusion. A conditional statement can be represented in symbols such as if P then Q, which is also read P implies Q. And I read it if P then Q. Either one, when you see the P and then the arrow and the Q, it means that this one implies that one. So there's a couple of examples that are fully worked out here for you to take a look at. I'm going to skip down and do some of these that are not worked out with you. The first set of directions says, identify the hypothesis and the conclusion of each conditional statement. So remember, the hypothesis is the part that follows the word if. So it's if the hypothesis, then the conclusion. So technically, the hypothesis doesn't include the word if, it's the part following the word if, and the conclusion doesn't include the word then, it's the part following the word then. So the first statement says, if it is Saturday, then there is no school. So we're supposed to identify the hypothesis and the conclusion. So the hypothesis, and I'm just going to put H for hypothesis, is going to be whatever follows the word if. So for this problem, it is Saturday is the hypothesis because it follows the word if. Then there is no school. So the conclusion, we have to find both the hypothesis and the conclusion. So the conclusion, I'm putting a C for conclusion, is going to be there is no school. So the hypothesis is that it is Saturday, and the conclusion is that there is no school. And we found that by finding the words after if for the hypothesis and after then gives us the conclusion. Number 2, if x minus 8 equals 32, then x equals 40. So x minus 8 equals 32 would be our hypothesis. And x equals 40 would be the conclusion. The part after the word if is the hypothesis. The part after the word then is the conclusion. Number 3, if a polygon has 4 right angles, then the polygon is a rectangle. So the words following if, which is a polygon has 4 right angles, that's our hypothesis. And the words following then, the polygon is a rectangle, is our conclusion. Okay, the next set says write each statement in if-then form. So these statements don't have an if and a then in them, but we have to add them in so that they make sense. So number 4, statement 4 says all apes love bananas. So we need an if, something, then something else. So we wouldn't say if all apes then love bananas. We need to kind of add some words in so that it makes sense in English. So if an animal is an ape, then it loves bananas. Would work. Now, is that the only way we could have said that? Probably not. But something pretty close to that. All right, number 5. The sum of the measures of complementary angles is 90. So we need to add an if and a then. So if two angles are complementary, then their sum equals 90 degrees. Okay. Number 6, collinear points lie on the same line. So if points are collinear, then they lie on the same line. All right, the next one says, determine the truth value of each conditional statement. If it's true, explain your reasoning. If it's false, give a counterexample. So here we're trying to figure out, is this a true statement or is this a false statement? And keep in mind in geometry that we say it's a false statement if it could ever be false. If there's even one counterexample which you could make that would show how it might not be true, then that statement in geometry is considered to be a false statement. Number 7 says, if today is Wednesday, then yesterday was Friday. So what do you think? Is that a true statement or a false statement? Today was Wednesday, then that means yesterday was Friday? I don't think so. That's a false statement. So we need to explain our reasoning. If today is Wednesday, then yesterday would be Tuesday, because Tuesday comes before Wednesday. Okay, number 8 says if A is positive, then 10A is greater than A. Remember from algebra, when you write 10A, that means 10 times A. So A is a positive number. If I multiply it times 10, is that going to be greater than whatever A was to start? I would say this is a true statement. If A is positive and multiplied by 10, the result is greater than A. Every time. Okay, next. We have some other types of statements that we're going to look at. We talked about conditional statements, but if you change the hypothesis or the conclusion of a conditional statement, you can form related conditional statements. And this chart shows 3 related conditionals, the converse, the inverse, and the contrapositive, and how they are related to the statement. So, the conditional statement is the one that we've already talked about. We just use the given hypothesis and conclusion. An example of that are if 2 angles are vertical angles, then they are congruent. The converse of the statement is where you reverse the hypothesis and the conclusion. Exchange the hypothesis and the conclusion. So the end becomes the beginning and the beginning becomes the end. The words if and then stay in the same place though. So if this was the conditional statement, if 2 angles are vertical angles, then they are congruent, the converse of that statement would be if 2 angles are congruent, then they are vertical angles. So notice vertical angles was the hypothesis here, vertical angles is the conclusion here. They are congruent was the conclusion here, are congruent is the hypothesis here. So we have exchanged the hypothesis and the conclusion. Now, the inverse, they have these little squiggles in front of these, and those squiggles mean that you have negated the statement. So instead of saying if P, we're saying if not P. You're replacing it with something with the word not usually. If not P, then not Q is what this means. So replacing the hypothesis with its negation and replacing the conclusion with its negation. So going back to the original conditional statement, if two angles are vertical angles, then they are congruent. They say if two angles are not vertical angles, then they are not congruent. So we've still started with the conditional, but we've added the word not in twice. Once into the hypothesis and once into the conclusion. That creates a statement called the inverse of the statement. Next, we have the contrapositive. The contrapositive is more like the converse. You take your converse, where you have switched the hypothesis and the conclusion, and you put the word not in both parts. So it's kind of really like combining these last two concepts. You're negating the hypothesis and you're negating the conclusion and you're switching their order. So we're saying if two angles are not congruent, notice the order is like the order of the converse here, then they are not vertical angles. Okay, so we've got the word not in both the hypothesis and the conclusion, but we've got the reverse order of the hypothesis and the conclusion from the original conditional statement. So at the bottom, oh, and here's a little statement about truth. Just as conditional statements can be true or false, the related conditionals can also be true or false. A conditional statement always has the same truth value as the contrapositive. Okay, so if the conditional is true, the contrapositive will be true also. And the converse and the inverse always have the same truth value. So if the converse is true, the inverse will also be true. Okay? So let's take a look at some examples of these. It says, write the converse, the inverse, and the contrapositive of each conditional statement. Determine whether each related conditional is true or false. If a statement is false, find its counterexample. Okay, so there's quite a bit of writing on these problems. Students sometimes ask, why are we doing all this writing in math class? Well, a big portion of geometry is thinking about reasoning, and reasoning is the name of our unit that we're in. So we have to be able to justify statements, and we have to be able to evaluate statements to see whether they are true or false. And so it's important to be able to kind of break them down and look at them from different angles. So that's why we're learning how to form these different statements and then consider whether or not they would be considered true or false. So on these three examples that we have, we're going to do quite a bit of writing. So if you need another sheet of paper to work on your notes, you may want to just grab some blank lined paper. So number one says, if you live in San Diego, then you live in California. So this is the original conditional statement. And this is a true statement because San Diego is a city inside the state of California. So now we're going to write the converse of this statement. And that means we're going to switch the hypothesis and the conclusion. So instead of saying, if you live in San Diego first, we're going to say if you live in California first, then you live in San Diego. So if you live in the state of California, does that necessarily mean that you live in the city of San Diego? I would say that is a false statement. And it says to find a counterexample. So the counterexample is that you could live in another city in California, like San Francisco. Or I could have said you live in Sacramento. There's many other cities in the state of California besides San Diego. Okay, so now we're going to write the inverse. We wrote the converse, now we're going to write the inverse of this statement. So the inverse, if you will remember, is the same order as the original conditional. So the hypothesis is the same hypothesis, the conclusion is the same conclusion, but we're adding the word not in both, okay? So we're starting with our original sentence that they gave us in the problem. If you, now would you say if you not live in San Diego? That doesn't sound quite right, does it? Sometimes you have to add more than just the word not to make it make sense. So if you do not live in San Diego, then you do not live in California. Okay, so we've put the word not in both the hypothesis and the conclusion. If you do not live in San Diego, then you do not live in California. Is that true or false? That would be false. And really the same counter example that we used for the converse would also work here. You could live in San Francisco and then you would still be in the state of California. So if you don't live in San Diego, that does not mean that you do not live in California. There are plenty of other places that you could live in California besides the city of San Diego. Just not living in San Diego doesn't mean that you don't live in the state of California. Okay, we have one more statement to write for this one, which is the contrapositive. Contrapositive statement is where we're going to basically start with the order that we had the converse, but put the word not in it twice. So we're starting with this converse statement. If you live in California, then you live in San Diego, but we're going to put nots in it. If you do not live in California, then you do not live in San Diego. So if you don't live in the state of California, then you do not live in the city of San Diego. That is a true statement. Because if you are outside of California, you're definitely not in San Diego. Okay? Number 2, this one is a shorter sentence, so maybe a little less writing, but we're still going to write all three, the converse, the inverse, and the contrapositive for this one. It says, if a polygon is a rectangle, then it is a square. Is that original statement true or false? That would be false. You can definitely draw a rectangle that's not a square. So just because you're saying it's a rectangle does not make it into a square. The converse of this statement would be if we're switching the hypothesis and the conclusion, a polygon is a square, then it is a rectangle. Is that statement true or false? Well, we haven't learned about quadrilaterals yet this year, but you've learned about them in middle school. And technically, if you're looking at a shape that is a square, it is also considered a rectangle because a rectangle is a 4-sided polygon with 4 right angles. And all squares are also 4 sides with 4 right angles. So squares are always in the category of rectangles. But not all rectangles have to be squares because in order to be a square, all 4 sides must also be congruent. So, if a polygon is a square, then it is a rectangle. That is a true statement. Now, let's write the inverse. To write the inverse, we're using the same order as the original statement, so the hypothesis is first and the conclusion is second, but we're putting the word not in it twice, once in the hypothesis and once in the conclusion. So if a polygon is not a rectangle, then it is not a square. So this is the exact same statement that we had to start, but we've added the word not twice, once in the hypothesis, once in the conclusion. And if it's not a rectangle, then it's not a square. That is a true statement. Notice that we talked about the converse and the inverse always have the same truth value. So the converse and the inverse were both false on number 1. The converse and the inverse are both true on number 2. Those will be matching always. Okay, so now we need to write the contrapositive. The contrapositive statement is where we start with the same order as the converse, so the conclusion is first and the hypothesis is second, but we have the not in both. So I'm going to start with this converse statement, if a polygon is a square, but I'm going to add the word not. If a polygon is not a square, and I'm going to write this then it is a rectangle with the word not in it, then it is not a rectangle. So if a polygon is not a square, then it is not a rectangle. That would be false. I can draw a picture of a polygon that's not a square but is a rectangle. So it would be like this. 4 right angles, short sides congruent, long sides congruent, but not all 4 sides congruent. Okay, number 3 says, if 2 angles are complementary, then the sum of their measures is 90. So that's a true statement. Now we're going to write the converse of this conditional statement. The converse is where we switch the hypothesis and the conclusion, which means the beginning and the end change places. So if the sum of the measures of 2 angles is 90, then they are complementary. So if the sum of the measures of 2 angles is 90, then they are complementary. That is true. Now we're going to write the inverse. The inverse of the statement is where we start with the original statement and we add the word not in twice. So if 2 angles are not complementary, then the sum of their measures is not 90. And that is also true. If 2 angles are not complementary, then the sums of their measures is not 90. Now let's talk about the contrapositive. The contrapositive says, if a polygon is not, I jumped up here to the number 2, I apologize. So the contrapositive is where we start with our converse statement and then we add the word not in twice to that one. So if the sum of the measures of two angles is not 90, then they are not complementary. If the sum of the measures of two angles is not 90, then they are not complementary. That is true also. All three statements here, the converse, the inverse, and the contrapositive, are all true. Okay, so we got to look at the hypothesis, the conclusion, if-then form, looking at conditional statements, converse statements, inverse statements, and contrapositive statements, and looking at whether or not they are true, how to write them and evaluating them. Now, we're also going to learn about biconditional statements. A biconditional statement is a statement in which both the conditional and the converse are both true. And in order to write a biconditional statement, we use the words if and only if. So when you see the words if and only if in a statement, it means that if you were to read it as the conditional, if then, and then you were to switch it to its converse, where you reverse the hypothesis and the conclusion, both would have to be true in order to make the biconditional statement true. So on number 1, it says two angles are complements if and only if, their measures have a sum of 90. So it says to write each biconditional statement as a conditional and its converse. So first we'll start with the conditional. If two angles are complements, then their sum is 90. Okay, so if two angles are complements, then their sum is 90. That is a true statement. Now we're going to write the converse. If the sum of two angles is 90, then they are complements. If the sum of two angles is 90, then they are complements. That is also true. So since both the conditional and the converse are true, the biconditional statement is also true. This one that we started with. It's a true statement because both of these are true. So when we see the words if and only if, we need to evaluate it as a conditional and as the converse, with the hypothesis and the conclusion switching places. And if both of those are true, then our original biconditional statement is true. Okay, the next one says there is no school if and only if it's Saturday. So our conditional statement is if there is no school, then it is Saturday. Is that a true statement or a false statement? If there's no school, then it's Saturday. I would say that's a false statement, and the reason I would say that's false is because it could be Sunday, it could be a school holiday, there could be a school closure. There's a lot of different situations that could be going on that don't mean it's Saturday just because there's no school. Now what about the converse? Is the converse statement true or false? If it's Saturday, then there is no school. That is a true statement. If it's Saturday, then there is no school. We don't hold school on Saturdays. Okay? well, technically, I guess it could be a Saturday school situation, but that's kind of a disciplinary situation, not just a regular school going on thing. Okay, number 3. So, would this overall statement be true or false? Well, if either of these came out to false, then the biconditional statement is false. Number 3 says, 2 lines intersect if and only if they are not horizontal. So we'll first start with the conditional. If 2 lines intersect, then they are not horizontal. So is it possible to have 2 lines intersect that are not horizontal? Well, sure. You could make like an X. These lines intersect and neither one is horizontal. If 2 lines intersect, then they are not horizontal. Might there be a horizontal line that intersects? Well, one of them could be horizontal if they're intersecting, but not both of them could be horizontal. So is that true or false? If 2 lines intersect, then they are not horizontal. Well, if I could make one of them horizontal, then one of the lines is horizontal. It would not be that they are not horizontal. So I'm going to say that's false. How about the converse? If 2 lines are horizontal, then they intersect. So I got 2 lines that are horizontal. They have to intersect. I see 2 lines, they're parallel, they are both horizontal, and they do not intersect. So, false. This statement is all kinds of baloney. It's just false. Okay. Not a true biconditional statement there. Number 4. Last one. The absolute value of 2x equals 4 if and only if x equals 2. And notice in the parentheses, they've also written this out with math symbols. So the absolute value of 2x is equal to 4 if and only if. That IFF is actually read if and only if. It's a shorthand notation for if and only if. So if you see that, it's a biconditional statement and it needs to be true both ways. Okay? So we're going to write it as a as a conditional and as a converse. If the absolute value of 2x is equal to 4, then x is equal to 2. Is that true or false? Well, if you plug a 2 in there, 2 times 2 is 4, and the absolute value of 4 is 4, so that is true with the x equals 2. But does x have to equal 2? What if x equaled negative 2? 2 times negative 2 is negative 4, and the absolute value of negative 4 is positive 4, so that would also be true. So x does not have to equal 2. X could also equal negative 2. So this is a false statement because I can come up with a counterexample where x equals negative 2, which would make it not true. Okay, now let's write the converse. If x equals 2, then the absolute value of 2x equals 4. If I have an x of 2, And then if I substitute that x in here, 2 times 2 is 4, and the absolute value of 4 is 4. So this one is true. But the overall biconditional statement with the if and only if is a false statement because the conditional is false, even though the converse is true. Okay, so I hope you have a whole lot of fun doing your math homework that feels a little bit less like math homework today. And put your thinking caps on because we're doing some geometric reasoning for sure. And I hope you have a wonderful day. Talk to you soon. Bye.